So good evening, everyone who's joining us. This is Michael Cassidy. And just before we start this evening's subject, I just thought for those of you perhaps who are not regular CAF members or attendees, they'll probably guess, I just want to tell you for 2 minutes how City Architecture Forum came into being. I was the first chairman nearly 30 years ago, and it was a product of the speech which the Prince of Wales made at the Mansion House in 1987. In fact, just recently I found a diary entry for 1987 which said tea at Highgrove, and when I went to that event there was a clutch of BBC television producers like a pride of lions on safari, looking and waiting for their prince's next intervention on architecture. Some of you will previous REBA event, which was controversial, and the Mansion House speech came about because I managed to persuade His Royal Highness that to do another REBA looked like intervening in a family row. Whereas if he came to the Mansion House, maybe that would be more neutral territory, and I could guarantee him a thoughtful welcome. As it happened, it was televised around the world because there were one or two purple passages in the speech, which certainly got people very excited, such as the looking at St. Paul's Cathedral through the then Paternoster Square was like seeing the Mona Lisa through a rugby scrum. There were others, I won't list them all, but they are firmly in my mind, and it led to some public reaction. And two of my colleagues at Guildhall, we were all three elected members of the council, said, why don't we show that we here in the city are responding to the Prince's speech with its criticisms, and that's how City Architecture Forum started. And we've continued it ever since, not as a lobbying group at all, but a sort of self-educating group interested in architecture with a focus on the City of London. And tonight is the latest of a series of these virtual events, since tours are not really on just at the moment. And I'm absolutely delighted that the subject that has been chosen for this evening is the building now under construction at 21 Moorfields, owned by Land Securities. I'm going to perhaps get a chance later to mention some features which involved my role as a board director at Crossrail for 10 years. I'm not going to do that now because I'm sure you all want to hear the story and then ask your questions after 7 o'clock. And just as a matter of how we're going to conduct things, I think you already know that use the Q&A feature to file your question or comment. I will then trace those and put them to our two guests to respond to, and we'll proceed that way. So with no further ado, I'm delighted that we're able to hear from two of the key participants in the project. You can see that they're present at the office at the moment. And so I'm going to introduce now Giles Martin and David Seel, who will say one or two words about their respective backgrounds and careers, and then take us straight into the presentation. So over to you both. Thank you.
Yes, good evening. I'm Giles Martin. I'm a director of WilkinsonEyre Architects. We're in my office in Clerkenwell, and
Yeah, good evening. I'm David Seel. I'm the Managing Director for Robert Berg Group, Structural Engineer.
Okay, without further ado, I'll take you into our presentation and give you a talk about the building. I'm assuming everyone can see that now. So we've both been working on the project for 8.5 years. Sounds like a very long time considering it's only half built, but it is the most difficult project I've ever worked on. Still got a couple of years to go, I might add. And when the City Architecture Foundation asked me to do a talk on it, the first thing I thought is that I'd like to involve Dave to take the talk with me, as it's really a collaboration between the architecture and the structure. The first thing I'd say is, well, WilkinsonEyre, our reputation is we don't get asked to design very many office buildings, and 21 Moorfields is really a bridge over a station, and our expertise over the last 25 years has really been bridges and stations. Dave and I were just talking about this earlier, and 8.5 years ago, well, Landsec brought them on. I didn't really know who they were, but their reputation was in construction and piling, and well, 21 Moorfields, if anything, is a piece of construction over a piece of piling. So in a way, we're both playing to our strengths and learning a lot along the way. So here's a picture of the site just after the war, well, 10 years after the war, actually. It's boxed in blue there. I mean, Moorgate Station was a cut and cover station with canopies along open platforms, and you can see what a landscape it was then subsequently developed into. As the Barbican got built, the London Wall development got built, and that whole piece of London became a rather 1960s, probably a lot of it not very characterable, but certainly something that you'll all know. Here's Moorgate Station today, and it doesn't look terribly like a London station. Generally, there are two stations and two platforms and 2 tracks, and here we have 6 platforms and tracks, and all under one cover. So the station was very much built over the lot in one go, and here's what it looked like when we took it on. You'll probably recognise it. This was the rather miserable place where you had to follow from Moorgate Station to the Barbican, following a yellow line through these courtyards and getting quite lost and alienated. And you can see they basically built over the station in one go, putting down columns in the platforms and these 3 slab blocks highlighted here in red. So this is, WilkinsonEyre have actually been working on the site for 25 years, ironically, as after doing the Jubilee Line extension, we got involved in Crossrail. And Crossrail trains are so long that the station is actually Liverpool Street and Moorgate, with the trains end to end and a canopy entrance at both ends, so one at Moorgate and one at Liverpool Street. And this slide shows the Liverpool Street canopy, which is now built. It's got a hoarding around it, waiting for the train lines to catch up. I don't know if Michael's going to tell us more about that. At the other end, it very nearly happened that we proposed this ticket hall, and it completely goes over Moorgate, the 6 lines plus the new 2 Moorgate Crossrail lines. And it very nearly was just a 1-story building in the city. And Michael, reminded me when I came to present it through the planning process that actually through the Crossrail development, he argued strongly that Crossrail should invest in putting in a pile right through the middle of the Crossrail station, and so that the building could then carry a development over the top. And WilkinsonEyre did a study to work out how this pile could be threaded down through the Crossrail tracks. And well, ironically, we didn't know we'd be back 8 years later trying to build a building over the top of the station. And in fact, Land Securities, when they appointed us to look at the station, to look at the oversight development, didn't know that we were the architects on the station. And there was nearly an embarrassing conversation where they said, "Oh, are you conflicted? We can easily find another architect if you don't want to do it." But luckily, we convinced them that we were the right people for the job. And luckily, too, we looked at it not just as a station in the ground floor of a building, but we thought actually you could lift the building above the station and let people flow underneath it. And if you think of how this part of London works, A, it's very dense, there's lots of people spilling out of Crossrail, but B, the Barbican is just behind, so creating a new level that people could use as a new bit of city with places to sit and places that trees are planted. So here's a drawing of the station, or the site in fact, with the roof peeled off. And well, first thing you notice is that the site comes up to roads on all four sides, and we've got nowhere to actually put down layover space to build a building. Second thing you notice, actually underneath the site, everything is used. So all the white area is all the station that you walk around, all the yellow is a circle line coming through, the purple coming in from the north is the Northern Line, and the blue, of course, is Crossrail. So the only place we had was to put down our structure was the two so pink zones at the north and south of this drawing. And Dave's just going to talk a bit about the piling and the structure of that.
Yeah, I mean, even within those orange zones, there were critical spaces within those zones that London Underground were using for their operations. Some of the spaces were mess rooms or changing rooms, locker rooms, and very much could be relocated, but other zones were for switch rooms or transformer rooms, cables powering the operation of Moorgate Station. So really it's a good picture of how heavily constrained the problem was underground, and Giles later will talk about above ground. So the first challenge, the first really big challenge from an engineering point of view we have to think about is how do you create foundations within an operating station? And it's important here that the agreement between our client Landsec and London Underground was that Moorgate Station would keep running with no interruption through the entire construction process. Where some other projects, oversight developments, have had the benefit of phased or periodic closures of stations, we had to work out a method. How could we do this while maintaining the full operation of the station all the way throughout? And on the screen here, I've just taken a couple of approaches. These approaches are relatively unconventional, but have been done. And in the middle there's an image I've credited Arup on their Claridge's project there for using a method called to dig hand-dug caissons. Also, that's the same method that was used for Exchange House at Broadgate by Skidmore, Owings and Merrill. And an alternative to that is a method that we used with Foggo Associates at Cannon Place on the right-hand side, and that was to create groups of mini piles. Now, both these approaches technically feasible, both create a lot of muck and disturbance in the station environment. And actually, one of the biggest constraints with the brief we were working to with Land Securities was both these methods would only give us about half the capacity that we needed at each of the support positions. So, Giles, if you'd move over. Yeah, so there was this light bulb moment really early on, and this was just a very exciting idea, different way to look at how to create foundations in the station environment. And it was to say, essentially, can we treat the deck and the roof over the station as our construction site and try not to be in the station environment at all? It needed us to create a full temporary steel deck over the top of the station. But what it opened up the possibility for was really large diameter piles to be used, very large piling rig, like you would essentially on a brownfield site. It also meant if we thought about how we designed the piles and the pile casing, you can see with the pink in the section sketch there, that pink's indicating a steel casing coming right through the station environment, up above onto the roof. So we could use the piling rig, and all the spoil that was arising out of the drilling operation would actually arrive up above the station and not therefore cause any disturbance.
I love this drawing because the piling driver is driving around on the roof of the station, and there's all these commuters waiting for to get on their train down below. And it really was built like that. That actually it ran 24 hours, so it was all through rush hour. Apparently, if you break the circle line, it costs £900,000 an hour. So we were very careful not to.
Just one last thing on the previous slide for a second there, Giles, if you can. On the left, that's a section of one of these piles to scale. It's just showing it goes right through the London clay, through the Lambeth group, and toes into the Thanet sand. That was really important to get the capacity that we needed, and I'll touch on that a little bit more.
So we knew that we could only build in those two strips of land, north and south of the station. And we thought, well, that can't be that hard. But when we got inside, well, then everyone had an opinion about where you could and couldn't build the piles. It's actually public-owned land, so we had to get mayoral approval. So these are images showing the actual piles themselves. We had to get approval for all of these, not just the fact that they're there on the drawing. And these shiny shoes on the bottom left, well, we actually had to go into these rooms with big wigs from London Underground and mark on the ground where the pile was going to come through. And I do remember a conversation where they were saying, oh, and we'll still need to be able to get to this fire extinguisher, you know, is that going to be possible? And of course, this pile is like this massive big drill coming right through the ground. Of course, that room was toast, you know, with nothing left after we left it, but we certainly managed to get away.
I think those images are showing pretty much the content of the first hour to hour and a half of our design team meetings through 2014 to 2017. And Giles, you loved every moment of those piling meetings, didn't you? Yeah. He would sometimes throw his toys a little bit and say, I'll come back when we're going to talk about the facade. It's a bit more interesting.
You're not wrong.
This is just, obviously this is an edited picture. It's just trying to show and give some understanding of what was above the station and what was below the station at the same time. So you can see all of the rusty steel there is the temporary steel grillage that we erected. The light blue crane is a slave crane. It weighs about 200 tonnes. And behind it there's a black mast, which is from the piling rig itself, again, another 200 tonnes. So you can just see that temporary steel grillage. It's spanning to the station columns, so it just means that the station roof's taking no loading, but we are temporarily supporting the weight of that piling operation on the station columns. And even getting the piling rigs onto the site was incredibly challenging at the size that they were and the constraints of the roads around the site. The image on the left is just indicating these huge temporary ramps we had to erect. And what you can't see there is that even to get the cranes to that position, the cranes were put together around the corner on 4th Street on SPMTs, the self-propelled modular transporters, radio controlled and very maneuverable. And they maneuvered around that bend up to the ramp and to the point that the piling rig could drive off. So even just to get the piling rigs onto the site was a bespoke operation. And here we're just indicating, you know, with the challenge underground, what did that free up for us and the form of the building, and we'll talk much more about that. But early on, I think the initial brief for the building, we expected it to be about 600,000 square feet. And for that building, we were designing these very large diameter piles to take 50 meganewtons, about 5,000 tonnes. Which had been done before. It was about the limit of what had been done before in London. But we went through several iterations, evolutions of the design, as you do with city buildings, several planning consents, eventually got a great, fantastic tenant on board. And at every single turn on the journey, the building was getting slightly bigger and slightly bigger. And as the building was getting bigger, the loadings on these piles was going up. So eventually we had quite a really big challenge. We needed, in order for the building to be viable to meet the brief of our tenant, we really had to push some of the envelope with piling technology and design these piles for a load that hadn't been done before. It's about 65 meganewtons. And in order to do that, we had a good theoretical basis for justifying that capacity, but we had to prove it. And this table and this image here is just showing the bespoke test pile rig that we put together to do that test. There's 4 piles being used as anchor piles, as tension piles, to generate a static compression force of 50 meganewtons. So we loaded this test pile to 5,000 tons, much higher than what has been done before on those other projects that are referenced there. And interestingly, the test pile performed much better than we thought. It was meant to fail at that level at 50 meganewtons. We extrapolated that it probably could have continued to carry load to somewhere between 60 to 70 meganewtons, so much higher than what we thought. And it opens up a thought that we have that actually there's more capacity to be explored in the Lambeth Group and the Thanet End. Maybe that enables more efficient development or taller buildings. And just an image here of the actual test pile structure that we created.
I'm not going to move off this section without saying these are the highest capacity piles ever built in London. So while that was going on below ground, we were struggling to find a form above ground. And you can imagine a building like this with such an extraordinary challenge and cost of building underground isn't going to get away unless you can absolutely maximize what's possible above ground. And I mean, we did that by basically creating a solid block and then cutting away all these constraints, such as the rights to light to the Barbican, that's the image in the top left, a setback on the upper floors that the city wanted to see from Moorfields, which is a smaller scale street than London Wall, and keeping out of a couple of specific sight lines, one of Finsbury Circus and another of St Paul's Cathedral from Westminster. And it's worth just looking at that view. Actually, if you ever go and stand in it, I thought it was a bit of a fuss over nothing until I went down and stood there. And it's a really impressive view because you're seeing St Paul's Cathedral set in blue sky. It's got kind of sky either side of it, behind the Royal Festival Hall. So you're sort of looking south and you can see the cathedral. So we would have been in the backdrop of this and we were forced not to. And this kind of created a crease across the roof of our building. So if you can see St Paul's at the top there, the crease behind what we call the crown on our building is created just by staying out of the view between the two church towers as you're looking from Westminster. And then this rotated upper floor facing towards Finsbury Circus is again an architectural response to a local setting. And interesting to see that if you look back in the past, buildings tried for this site, and these are 2 by Foster, one from the mid-90s and one from the mid-noughties. They both effectively tried to keep out of this view from Finsbury Circus by stepping down towards Moorfields in a similar way how we stepped down towards the Barbican to the south. To the west. And we said, well, no, actually, we're going to rotate our facade and look straight down the avenue of the, centre ourselves on the avenue of the circus. And the city, Peter Rees was at the time, found this a very attractive urban move and was very supportive of actually having a bigger building to the south. So effectively, we were able to gain a lot more mass by making this urban design response. So if you think about this building then, it's a real piece of railway architecture and probably the most expressive bit of railway architecture being built above Crossrail. That's probably setting myself up to fail with that statement, but in a way it's something I think we do very well in the city. Exchange House is a beautiful big arch over Liverpool Street and Cannon Place similarly over Cannon Street Station. And it's something, again, that we were very proud of exploring. The challenge for us, though, was that the chaos of the placing of the piles and the sort of randomness of the different section of each truss across the length of the site is very difficult to create anything approaching an architectural expressive form. And that for us has been the real challenge of making this into a piece of architecture. And I think the answer really came from really getting into the structure and really understanding the structure and making it do the talking. And over to you, Dave.
So here we're just going to take a bit of a journey through the evolution of the main elements that bridge across the station. Both this is a condition that is across the middle portion of the massing. Then we've got different conditions in the elevations, which we'll come to. But this is like right back at the very early stages of, how do we bridge across the station? What are the different approaches that we might consider? And quite conventional trussed forms on the top of the screen here. The benefit of these being that once they're installed, the building's pretty conventional above that and unimpeded by structure. But because the bridging structure is pretty compact and condensed within the lower floors, very intensive in terms of the usage of steel. And then at the bottom two images, different approaches using an arched form, and of course gaining that extra overall height in the height of the structure bridging across the station brings an efficiency, but of course then that structure is coming into the space, and the functionality of the space needs to be considered carefully. But one unique thing about our thinking on this project was when using something like an arch or something as deep as that over, say, 10 stories, the structure doesn't really do the job of bridging until that 10th story is in and the full bridging structure is available. So it can create a condition where a lot of temporary works is needed to support the structure until that element's in. We tried to think here differently about the incremental creation of a bridging structure. So firstly, using a compact trussed form at the bottom part of the structure to give us capacity to build the frame above that. And then as we build the frame, we create the primary bridging structure. And by doing that, we minimize temporary works. We make the build very simple. We established this launching truss, we called it, at the bottom, and then we build relatively conventionally from there. And even the launching truss, we evolved our thinking quite a lot in the journey with Giles and Giles's team. Initially, on the left-hand side here, we thought, as you do, a heavy truss structure, we want to hide that, or let's call it integrate that with the plant space and the loading base, so it's not seen in the spaces. And that was quite compact, it wasn't very efficient, and it also made it quite difficult to work around in those spaces. And Giles and Giles's team were really open-minded to how do we actually embrace this and make it part of the architecture. And so it was much more efficient to move toward, and we eventually are delivering this design on the right-hand side here, where the launching truss has moved up into level 1.
So originally, where it was in the plant zone, you basically had to drive all the trucks in, and the loading dock and the water tank and the oil store, and all these things had to sit alongside these massive big trusses across the space. And we had this emergency meeting saying we just can't fit these things in, and Robert Bird suggesting we're going to move this up to the upper level. Could we live with that? And we thought, well, actually, suddenly it's a great thing. So everyone walks through it every day, and you're actually aware once you're in the building that you're in this massive big truss, or this series of trusses, and the main street of the building goes down through the arch one after another. And here it is. I took that picture on the right yesterday, and the actual, those big columns will be there forever, and they define all the big main spaces on the primary open level of the building when it's finished.
So with this concept to launch the frame on a launching truss, the launching truss in red here, we then started to think with Giles and Land Securities and the letting agents as well about how do we form the primary bridging structure. And the thought initially was this Queen's Post truss concept, where essentially we've got two raking sections. They're close to vertical, or as close to vertical as we can make them, so that they don't intrude into the space so much. Well, that was the view at the time. But I guess what we found as we analysed this is you can imagine the loading on the floors in the middle of this system where the vertical bracing is shown. That floor loading is having to hang up to the node of the queen post truss at the top of the frame, and then strutting compression back down. It's a really long load path and not a particularly efficient one. So we started to think more about how do we bring more efficiency to this form. So some topology optimization, sort of form finding analysis on the left-hand side here, giving the computer a bit of freedom to, we set the constraints of where the vertical column grids were, but giving the computer a bit of freedom about the geometry of a bridging structure. And it's sort of returning something quite intuitive, of course, that an arch is the more efficient form. But interestingly, it's also returning here the height of the arch is more efficient around about this level. And I'll come on to that as well on the next slide. Yeah, here not particularly graphic, sorry, apologies being the engineer, but the graph on the right-hand side is showing, on the bottom axis is showing material usage, and on the right-hand side of that axis is increasing material, on the left-hand side is less material. And on the vertical axis of this graph, we're just showing the crown piece of the arch, how high is the arch. And interesting, you can see there's a sweet spot, and the sweet spot we might have expected would be more specific, maybe at one level, but we can see here there's a zone that is a sweet spot. Around about 8 to 11 levels was the optimal height for the arch structure. And here also, these next three images just indicate how the frame actually becomes, erected and built off this launching truss, and indicates some of the force parts. That's just showing the assembly of the launching truss initially. Jump to the next one. And as we build the frame up, you can see vertical loads coming onto the launching truss here, but we don't have the arch assembled, so the arch is not contributing to spanning across the station at this point. And you can see in the launching truss, the red arrows are compression, blue arrows are in tension, just conventional bending action in that launching truss section. Then once we form the arch starts to contribute in its way as a primary bridging element. It's carrying compression thrusts indicated by those red arrows. And as they land at the base nodes, they start to induce this tension into the launching truss. It actually reverses the compression that was in the top chord of the launching truss and puts that chord back into tension. So we're getting a full load reversal in that element. It means we're actually using it really efficiently in the temporary case to help us build this, and then we're reversing its load in the permanent case. So we're sort of getting two birds with one stone, you could say.
So here's the first arch that was closed, and to me this is such a great picture because it's a bit like sort of docking at the space station or something. You've kind of achieved what you set out to do, and from now on, every steel we put in will be hung from this arch. And how old is that photograph? Probably about 2 months.
6 weeks, I'd say, probably something like
so
that.
We're right at the cusp of kind of joining this building up, and meanwhile the Circle Line is thundering through every day. So the final bit of the story that we just wanted to tell is to do with the east face truss, which is probably the most special bit because it's maybe not the most difficult, but it's probably the most special because it's the bit that everyone will see every day as they walk to work and go past the building. And it's a real sort of look no hands moment of floating over the public space and the station below. So, I mean, we've had to be solving this problem ever since we started on the project, and we knew that it was going to cantilever 11, 12 meters in one direction and span 48 in the other. And it kind of tessellated into a grid of 11 bays across and 7 stories high. And as these are both prime numbers, it gave us a bit of a problem to kind of find a pattern that kind of was easy to recognize and felt like something that we recognize as the front of the building. It's worth saying that 11 bays is 12 columns, which is quite a special number. The only other buildings I know of in the city with 12 columns on the front are St Paul's Cathedral and the Bank of England, but still enough about that.
I'd just say also, I mean, we were really excited at this point here. Giles was very clear at this point. He said, I'd like the structure to express the elements that are really doing the work. I'd like that to be felt from what you see when you look at the structure. We were very excited by that notion and the challenge, but also looking at the initial sketch here, the feedback from the engineer, Giles, was, from my point of view, it's such a long load path to have diagonals that hang in that way over the full height of the structure, that type of form is not the way it wants to carry the forces. So we started with this diagram on the screen now, responding to Giles's concept initially by saying, how does the structure how do the forces want to flow within the structure, and starting to draw these force path diagrams. And you can see on this diagram, it's indicating a primary blue compression arch, but equally, if you flip that upside down, the red is trying to indicate that there are tension catenary paths as well that are trying to pick up these forces in green that are coming onto the structure and then hang them back. But at this point in time, we just had 2 support points, and the geometry, as you said, Giles, wasn't quite working.
And it grew into this, which is a Robert Baird drawing of, and you can see the bones of the idea of the big arch, and also the launching truss is there. But it didn't quite, because of the 11 bays, didn't quite turn into what we wanted it to be. But we suddenly had this light bulb moment that if instead of landing on one point, it landed on 2 points, and you had a tripod or a V to catch it, that you could create this very simple pattern of a sort of repeating fish, sort of slotting together as it goes across the facade. And it still has symmetry, but it's now rotational symmetry, because it's a sort of 5.5 bays across. So what's an upside down fish on the left is a right way up fish on the right, and vice versa. And we still allowed the main primary arch, just by the fact that some of the steels are bigger than others. We allowed it to express itself as this big sort of lazy loop over the top of the truss. Oh, you need the mouse. Yeah.
So I'm just going to try something with this slide to indicate some load paths. So we ended up with this really interesting load path. So these are the columns that are set back in the taller part of the building. And those columns come down, they land onto a bowstring truss at the base level. We didn't want to have any trusses in the office space, of course. Wanted to keep the office space totally clear. So these bowstring trusses then span from the grid behind to the front grid as well, and they deposit this force that hangs from the east face truss. And these red dots here are going to indicate the primary force paths through the east face truss. And then as the yellow comes on, indicating secondary force paths as they flow through the east face truss. So it's an interesting form that does create quite relatively direct load paths for the primary paths, and then creates a lot of redundancy in the frame as well, and the presence of secondary load paths.
But the thing that it threw up was that the building would land on this tripod. And of course, this actually stands in the main public space of the building, and it's this kind of shallow hand holding the whole building. And it's taken this extraordinary force down through Crossrail. That image on the right is the actual tripod base. It's 27 tons and 2,000 hours of welding to create that single block just lifted into space there. But it'll always be there as this one main primary space of the building.
Yeah, just for a bit of scale, the plate sections that are forming that node are 200 millimetre thick pieces of plate.
So now we knew it was a building about the connections, about the big striking lines of the trusses. We did a whole architectural set of drawings that went to the steel fabricator of how exactly we wanted those connections to look. And of course, some of them are fancifully out of the kind of architect's playbook of big bolts and recesses and shadow gaps, things that the steel fabricator was really not accustomed to working with. You have to think that a steel fabricator might one day be building an oil rig, or one day be building a power station, and here we were asking them to create a column that would be compared to other classical columns in the city. And, you know, expressing the verticals with no signs of fixing with welded cover plates, and the diagonals with these big bolts and upwelds, and showing a shadow gap of how the flange meets from one to the other, has been something that we've brought them along on that journey, and they're just as excited about it as we are now. And then here is the truss. Similarly to the launching truss Dave was describing earlier, it's got a temporary cord on the 5th floor that's holding the whole thing together. It's now, again, about 6 weeks, it's now self-supporting. You can go and look up. It's covered in scaffolding now, actually. I'm afraid you can't look up. But that steel, the rusty steel will go, and the big true kite shape will come into form and be the recognisable emblem of the building.
And of course, later on, once the elevation is in place, that say rusty steel cord gets removed at that point. So it's an efficient way to use the primary structure to support itself in the temporary case.
So as we went through the design process, and I did say, I mean, this has been 8.5 years, and we did 3 planning applications, and each time the building got bigger and the public space got smaller, and we had to think of new ways to go back to the city and say, we've got this great idea for this public space, and actually it's got more exciting in a way. So there's little courtyard gardens. We got Andy Sturgeon, the sort of Chelsea Flower Show garden designer, to design us a little garden. And as you walk along the south of the building, you're on the high walk, and we're growing plants on these cables that are mimicking the big shapes of the trusses, and light works projected on the other side of the wall. And Michael was alluding to Crossrail putting in this, we're pedestrianising the front of Moorfields, and Crossrail are putting in this beautiful big, if you see in the top right there, or middle right there, this big piece by Conrad Shawcross. And it's the terminus of the cultural mile that's come all the way from the Museum of London on the other side, drops you down our external escalators into this new square. And we met with Conrad Shawcross, and we discussed this big structural steel piece in rusty metal, mimicking or playing off against the big gestural diagonals of the truss, which has been very inspirational to him. And then here's the building as it'll be finally finished. We're up to about halfway. And it's now a big new headquarters for Deutsche Bank. We had to redesign it again to get them in, but you can see how it could work for them with Crossrail coming up from below, all their loading and plant space at the ground floor above the station. Above that, their public-facing areas, a Barbican level with an auditorium and their art gallery and so on. And then above that, these massive dealer floors, literally the size of football fields, with the glass lifts coming through those, and you can see the engine of the bank in operation. And then as you get to the top, the form breaks down and creates these courtyard spaces and atrium spaces with lovely daylight, and then there's terracing gardens on the rooftop facing out to the west. And that's where I'm going to leave it. And if I can remember how to stop sharing, I'll come back to us.
Thank you very much. And I'm sure we're going to have a series of questions on that design and the problems that you were able to overcome. So let me just remind everyone to place their questions and comments in the Q&A box, and I'll pick them up as they arrive. Let me just start on that planning front, if I may. And there's a couple of, maybe 3 different elements I'd like to explore at this point. The huge truss that was the huge pile that was put in order to support the building, or any building actually, was necessary at an early stage in the conception. It was even pre-construction of Crossrail. It was the conception period at a particular point when, well, George Osborne was the Chancellor, and he wanted £1 billion off the Crossrail bill. And so a huge exercise was undertaken quite early on in the 10 years that I was involved. And one of the ways of achieving the saving was to eliminate that big pile. And I recall the budget to construct it was £10 million. And I think it was encased in steel, which would have added to the cost, wouldn't it, in order to give it strengthening. And I can remember saying, we had a special board to discuss this, and I can remember saying at that time, given my backdrop of my career in city planning as chairman of the planning committee, that without this feature, there would never be an office building on that site. Now, would that be true? Was it that crucial?
I think you could have built a building one block back, so from the back of Crossrail onwards, but you wouldn't have been able to see it. So it'd be very hard to let. Crossrail would be one-story building in front of it, for 20 metres in front of it. So I think it was absolutely crucial to put it in for creating a curb appeal for the building. But not just that, of course, as you saw the section of available developable space, terraces, tapers to the west. So actually about a third of the building is standing on that front area because that's the only very tall bit. And a third of 5,000 bankers is a lot of building.
And then you said that it took several approaches to the city corporation to reach the design that you've just been describing, 3 stages. What were the primary drivers for that, please?
Well, Landsec's primary drivers were, what's the biggest building we can get on this side? I mean, a lot of others besides. But the first one, when we got consent, and the city did feel this was the biggest building they could stomach on the site. It was quite a lot bigger than the existing building and in a sensitive area, but it got consent. But when Landsec came to actually look at whether they could afford to build it, they just couldn't make the numbers back up. And we went back to Landsec and said, here's an idea. We'll build the west building just on the existing structure and save putting in those expensive piles. And it'll be a much smaller building, but we'll put an extra floor in the big building, which is a much more valuable floor because it's at the top of the building. And the money go round suddenly made the building to be viable. But what was more important is that it was still, they didn't sell the site off, which they might have done, but it was still a going concern when Deutsche Bank came knocking and said, do you think it could work for us? And had we not, done that second planning application, it might have not got into Deutsche Bank's top 3 of where they might want to move to.
Yes. It has been said that the height that resulted from that third planning application and the ascent of the city to it has set a new height standard for that part of Moorgate. Would you think that was overstating things?
I don't think it got notably bigger. I mean, it did take up more of the public realm because the public space got smaller, but had to work harder. And we worked very hard with the city in that third planning application to bring them along that it was actually going to be a very exciting space, very appropriate space, more like the little churchyards and cut-throughs that you get in the city. The building didn't get bigger. I mean, the other one was St. Paul's Cathedral.
Yes.
Several meetings at the top of the dome where the surveyor of the fabric has his office to explain to him that we were going to have to raise the parapet by about 300 millimetres. But that grew through the section that I showed you in the aerial view. It never got so big that it started to eat into their view.
No, and we got Ropemaker going up now, of course, which is another dimension further. Good. Let me go into questions and comments. We've got David King with us, who was the genius behind the America Square structure. out at Fenchurch Street, and he asks, was this particular structural solution ever considered for overhead at Waterloo by any chance that you know about?
The Waterloo structure has had a variety of different designs over the years. We're designing it at present for HB Reavis, and it's a different design in some ways. It's very much a more pure arch form, so it's quite a curved arching structure, whereas this one is more tangential. It is a much bigger challenge, to be fair. I think this building is an immense challenge, 21 Moorfields, no question. But Elizabeth House next to Waterloo International is about 4 times the challenge in a sense. It's twice the development area and the span is about twice as far. So we actually did an exercise in the office where we took the cross section of this bridging structure and put it over the building section for Elizabeth House, and you fit about 4 times 21M into that bridging structure.
So this is just practice for that?
Well, we learned a lot of things on this development, to be fair. I don't know if that's really answered David's question very well, but yeah, the concepts we're using are quite similar, but the form of the arch is quite different.
Thank you very much. And then Stephen Bradley from Gleeds asks, can you explain how innovation in procurement and collaboration was used to bring the supply chain into the design process at the earliest opportunity?
Sure can. Yeah, I mean, Stephen, thank you for the question, and it's good to hear from you. Stephen was a principal working for Gleeds on the project with us. Yeah, on this project, it was invaluable that we had early engagement with the specialist supply chain. So in particular for us, the piling, we knew we were pushing the envelope with respect to the design of the piling and the capacities we needed to achieve. And Cementation Skanska were brought in very early to work with us on that. And likewise, the bridging structure, the steelwork design, the client, Land Securities with Gleeds advice brought on hairs at a very early stage in an early engagement appointment, so that we could bring in all of the expert knowledge into the design at stage, I mean, we were calling it stage D at the time, weren't we? Stage 3 now.
So it was kind of pre-planning. We were already talking to people who were going to make this thing, which is quite interesting. I mean, for us, the challenge was the cladding, because although it's in some regards a fairly conventional glass-clad building, the extraordinary movements in an arch that, the facade is 60 meters long. It's 150 mil longer on a hot day than a cold day, and all the movement joints had to be taken into account, and you couldn't really have gone to the market and bought that cladding without knowing all of those elements. And the other 2 were M&E and lifts. So those kind of 5 packages were all effectively done and dusted by the time we went out to a main contract.
Yeah. And then from me, just on sustainability, is there anything that features in the design of this particular building that contributes to the debate on sustainability?
Well, I would say that a big mega bank like this isn't the most sustainable building in the world. And I'd also say that we started 8.5 years ago, and an awful lot of decisions are kind of put in train in that time. And I think possibly it would have different features now. I mean, it's BREEAM Excellent. It was designed to link straight into CityGen. It's got a kind of blue roof and great kind of projects on the sort of biodiversity side, but it is a big steel building, running on, high energy, or albeit very, very low energy services by comparison.
Thank you. And then, is there a retail element that you could highlight in the ground floor or thereabouts?
Well, there was much more retail in the earlier 2 planning applications, and we did look hard at retail with Deutsche Bank, but the space had kind of got too small. I mean, there is a big gym building at the back building which will have public access, and there's a restaurant or cafe facing onto that little square. But all the ground floor retail effectively has been was effectively snuffed out by putting the big Crossrail box at the front. So it's never been that retail focus since the Crossrail scheme came along.
Yeah, but of course, just across Moorfields, fronting Moorgate, there's plenty of scope there for retail as there was before. So
and I must you remind me that actually the Barbican were rather against having retail over at the western end.
Of course. So, yeah. Well, very good. That's been fascinating. I'd like to thank Giles and David extremely for the effort they put into presenting the design. I like to think that this is a building that might never have been, in my romantic view, but it has come about thanks to your concentrated effort over those years. And it certainly stands out as being a very commanding, fascinating design, and one which will play its part in the future skyline of the city. So can I thank you most sincerely on behalf of the forum for your efforts today. Thank you.
Thank you for having us.
Pleasure. Thank you.
And then for the members and guests, just in 1 minute before we sign off, I've been asked to mention the next CAF event, which is 24th of November. And we're going to move from Moorgate across to Liverpool Street. In fact, this is going to feature the building at 100 Liverpool Street, which incidentally also has a Crossrail work of art now being fabricated in front of it. And the architects, they're Hopkins, and it's a British Land site. And so we have representatives of both of those organisations presenting to us on the 24th of November. So at that point, on the dot of 7:30, I'm going to thank everyone for taking part and look forward to seeing you next time. Thank you very much.
Thank you.